a 3D printer running on Windows. This will be a more of a old-style proper printing video. Just me behind the computer and a 3D printer that we are going to modify. The project receives support from the European Regional Development Fund through the Northern Netherlands Alliance, and thanks to Prusia for sponsoring this project and sponsoring the studio. This is the Fuck Around Excel. This is our experimental platform on which we are going to print the weirdest, most cursed materials you can think of. So not just plastics, I want to print with glue, concrete, resin again, and many other materials. And I'm using the Prusia XL because I'm especially interested in the combinations of all of these materials, with the goal to find new use cases and just find out what's possible in the world of additive manufacturing, to put it nicely. I started this project by replacing the 5 tools with my own extruder, and this allowed me to, well, now I know how this works, how the hardware works, and now I'm confident that I can replace those tools with whatever tool we need to print all the weird materials. So I have control over the hardware now, but we are still restricted by the software. And that's what will be focusing on in this video. Usually the 3D printer is controlled by the file that's generated by the slicer. So you import your 3D file, you slice it, and the slicer generates G-code, which is code that the 3D printer understands. So I made a fun video a while back explaining G-code, explaining what it does, how the firmware reacts to it. But we are not going to generate files using a slicer and run it from the USB stick. I'm going to send them directly from my computer to the 3D printer. So, and luckily, the Prusia XL has a USB port on the back. It should show up as a communication port. Turn on. So now I have connected the computer to the 3D printer. I turn on the 3D printer and we have a USB serial port. With this serial port, we can send commands directly to this 3D printer. You can use a terminal, for instance. And I'm a big fan of Termite. When I'm using Termite, it opens a connection between the computer and the printer through the serial port, and I can send commands to the 3D printer, and the 3D printer can also send commands back that will be shown here in this terminal. So if I send the very famous G-code G28, which is homing, it will go through the homing sequence. And I didn't know that. That's funny. It shows the logo of Octoprint. So the printer assumes that it's being controlled by Octoprint now. Okay. It still works. We have a 3D printer and we can send our individual G-code lines over USB. So there's that. But we want to take it a step further, of course. The software I'm going to use for controlling this thing is LabVIEW. LabVIEW is a graphical programming interface, and it's very capable. Maybe it doesn't look like it, but LabVIEW is actually very suitable for this. For me, the initial reason for using this is that I've been a LabVIEW programmer for over a decade. When I worked at Philips and Varias as a test developer, I've used LabVIEW for controlling test systems, and LabVIEW is very good at controlling hardware, at controlling instruments like power supplies, oscilloscopes, whatever. And this is just another piece of hardware that we can communicate with, and it happens to be in the shape of a 3D printer. I've done this in the past. In an old video, I made a whole 3D printer controller that actually looked pretty cool. I've made Marlin instrument drivers, and with those drivers, it's really easy to build your program and automate the 3D printer. So with this, I have a lot of power over this machine. I can imagine that some would say that this doesn't make sense, use real software, and I agree. But we are in a different stage. We are in a stage of experimentation. That means that this, what you will see in these videos, it will not be an end product. That's not the goal. The goal is to experiment, to see what's possible, to just play around. And if we find some interesting use cases that could have potential in the future, then we can maybe look at final solutions in the form of a actual software package. I also don't want to vibe code the shit out of this because I want to know exactly what's happening. And when I use LabVIEW in combination with this 3D printer, for most part, I know exactly what's happening, what's possible, and how to properly fuck this thing up. Some of you already know that I moved to Prague, and my flawless Dutch accent makes it clear that I'm from the Netherlands. This comes with some struggles, especially because my Czech is kind of rusty. That's already hard enough with the contracts I have to sign, so if I can get at least some things from my home country here, that would be great. That's why I'm using NordVPN, which is also the sponsor of this video. With NordVPN, it's like I'm back in the Netherlands when it comes to my digital life. Many websites are not in Czech anymore, and I have access again to some local content that I otherwise have no access to. Yeah! Not only do they provide the world's leading VPN, it's combined with a next generation antivirus that helps protect users from scams, fake shops, and everyday threats. Where many traditional antivirus won't act until the malicious file is already on the device, NordVPN intercepts the threat at the source. I'm also using NordPass besides NordVPN for quite some time now to securely store my passwords and generate unique passwords for every website. Quite often I'm working in a cafe using public Wi-Fi, and it's nice knowing that I can do my work safely, wherever I am. So check the link in the description if you're interested in the peace of mind yourself. I connected remotely to that Windows laptop and cloned the repo from GitHub. Apparently this was already 5 years old, which surprised me. I opened the project and it was fun to see how I built it back then. Good old LabVIEW. You need to be a special kind of person in order to like this. So if I open a new VI, virtual instrument, it always comes with a front panel and a block diagram. The front panel is what the user sees. The block diagram is where our code is made. So let's make a very simple program using the device drivers that I made, Marlin instrument drivers, and place our first block. We can set a COM port, COM4. And this will initialize the COM port, and we can do something with our system now. So let's go and select home and connect these wires. Close our connection like that. So, and now let's just run this program and see what happens. You can also hit this icon and we see that this is now running. And once it's done homing, it homes the set. Yes, and there we are. Our printer has homed. So, what we can also do is set which axis we want to home. So I can create a control. And now if we go to our front panel, we can select which axis we want to home. So let's say that we only want to home the x-axis. Run the VI again. It will initialize the port again. And now it will only home the x-axis. Right now we have a program here. When we run it, it will home. But we also want to make something that the user can interact with. We can make a button, big button, execute. Yes, we need to add functionality to this button. So what we can do is add a event structure and add a event. When this button changes, an event will trigger. And now I'm going to show you something really horrible, but it works. Now we run it and nothing happens because it's waiting for our event. And I can do highlight our flow. And now if I hit this button, it will home X and Y. No idea what that thing just did. And this shows a problem. Yes. So we did something wrong right now. And this also shows why this is a terrible practice. The printer is right now in a fucked state. Something went wrong. But also the software hangs. I cannot even control these anymore. Execute. This is just stuck inside here, which is pretty frustrating from a user's perspective. Normally you only use the event structure to deal with the UI. So the UI is always responsive. It's very important. And in parallel, there is a loop that deals with controlling the hardware. So now we have basic functionality with UI that works. Let's reset the printer. When I run this VI, it will initialize, and now it will wait for our queue. So we want our 3 axes homed. So when I, as a user, modify this, it triggers an event and it updated our axes. And now I say execute, and it will execute our homing sequence. And if you continue adding stuff and adding stuff, I did that over the last couple of days. Every free moment I found, I was in full programming mode. And at some point, you will end up with something like this. Okay, this escalated a bit. The reason why this is why it looks like it does, why it has this 4:3 aspect ratio, is because I think that it would. Well, I bought a touchscreen monitor and mounted this to the 3D printer. I thought about mounting this display to the printer and calling it a day, but this project deserves better. I wanted to go for that industrial look, and that's exactly what I got when I removed that enclosure. It even had screw mounts on the side. I did some measurements, but realized that there might be a datasheet of this specific model. And there it was, including a mechanical drawing. I removed the bottom of the Excel enclosure and received spare parts from Prussia. My idea was to duplicate the side panel to close the whole side. I think that this makes a lot of sense, although maybe this is not the best way of mounting those profiles. I 3D printed the first prototype of the display enclosure out of white PLA and mounted this to the front. It was not aligned well though, so I had to make some modifications. I quickly tried if it was still working, and it did. By the way, I use white PLA for prototyping because this is like a 3D notepad. I printed the new parts out of Galaxy Black because that fits well with the printer. The 4 corners are hammered together and I added inserts for the bracket. I mounted that bracket on one side, so I was able to place the whole display on the side and hammer the rest together. After mounting the other side of the bracket, I used a brass tube for the hinge. This is easy to cut to the right length, and I mounted this assembly to the front of the printer. This time I was able to align it properly. I modified some aluminum corners that I used to secure the 2 new profiles at the front. I mounted the panels in the same way as the originals and mounted the last part that closes everything off nicely. A 3D printer running on Windows. Okay, on the inside it's just a laptop, but I have already ordered a mini PC that I will build inside of this thing, so it's more of a standalone thing. I will just run OBS on this thing, so I can do screen capture. Okay, start recording. So what I've built is, let's run it. This is the UI that shows the 5 tools in the same colors as the original tools here. And I also, while I was reading out the temperatures, I found out that I can read every individual temperature of the heating tiles of this bed. There are 16, and let me give you a quick demonstration here, because that's actually pretty cool. It took me way too long to make this, to convert a temperature into a color, but trust me, it is definitely worth it, I think. So if I will start heating up one corner of the bed, then you can see it going up in that corner. Isn't this fucking awesome? So I added this because I can, but also I'm just curious if I'm going to 3D print something small, if only the tiles where the print is on, if those are activated, and I think that that would look pretty cool. Yes, if I'm going to home all axes, okay, and now I can select tool 1. And I can also jog 50 millimeters. And this is through machine HMI panel, and this is so cool. And if I want to select tool 3, it will go to tool 3. And if I want to preheat tool 3 to, let's say, 200 degrees, I can turn it on, and it will heat up tool 3 to 200 degrees. So fucking sick. So let's turn it off, and I can select tool 4. So this is super satisfying. I can also extrude and retract or move the Z-axis 50 millimeters down. So there it goes. So I have control over that. And I can also have, I made a whole terminal with commands in case I don't have the keyboard here. So I can send some custom commands if I want. I have some settings which only shows the COM port. I can imagine that some skeptics would say that it's just a monitor, nothing special, and a simple controller. I didn't add any new functionality to it besides a flashy user interface, and that's true. But this is just a start, and think about the possibilities this enables. One thing I want to do is 3D print with hot glue sticks again. And so if we have, maybe you've seen this old video where I had this thing on top of a 3D printer that can index new rods for it to drop down on a tool. And I think it would be really epic to have a system like this on top of the Prusa XL, have a tool move below the stick dispenser, drop in a stick and continue printing. That would be really hilarious. But I need to have something controlling this motor. So if I have another controller, I can also connect this to the computer, and just it will have a different COM port. And if I need some functionality like, okay, the stick ran out, drop in, move to this position, drop in a new stick. It can just say, okay, I detected a stick running out. Then it will say to this printer, move to this position, and then it can send a command to this board saying, okay, move this stick dispenser, and then continue with the G-code. Because if I generate a G-code file, I can just open this with LabVIEW and run all the individual lines like I did before, and I can just manipulate that file. I can add custom actions. I can make my custom commands if I want. There's so much. Now, okay, another example, and that's will be next. Because an issue we have with this printer is that the maximum tool offsets is 1 millimeter between the tools, because the XL expects 5 of the same tools. You can set the tool offsets using the calibration pin in the center, and it will touch it all around. But imagine, and I bought something really cool. Imagine just using a USB microscope, mounting that to the center of the bed, and have a view of the microscope here in the UI. It's the tool offset calibration, it's empty. But I can make my own calibration procedure. So I can say start the calibration, and it will pick up the first tool. It will move the bed far enough down. It will say towards the user, mount the calibration tool, and it will show the stream of this webcam with a crosshair overlay and have the same controls as this, jogging, and have the first tool right on top of it, just aligned, and then said, okay, this is the 0 position of tool 1, and the exact position, I don't care. I will select the second tool and it will go to the same position, and I can jog to align that second tool, and then I know the distance between those tools. And on the firmware, I can just set all tools to 0 and have LabVIEW store all the tool offsets in some kind of XML or config file. And when I generate a G-code, send it to LabVIEW, and have LabVIEW control this printer, then when it detects that it's in a different tool, it will just manipulate the G-code on the fly. It can just add the tool offsets to the file itself while it's controlling it. I hope that you followed along. Long story short, this is fucking awesome, and this enables a lot of stuff that I'm planning to do. And I don't even think that I need to modify the firmware, to be honest. I will try to have as much functionality as possible with the firmware as it is. And we will just start experimenting more and more on this machine and just find out what's possible. So, if you don't want to miss that, then definitely subscribe. I want to say special thanks to my Patreon supporters, especially my top tier Patreon supporters. I still have to place your names on the wall, but I will do that soon. Thank you for watching, and see you in the next video. Bye.